We've been working with groups since we were really little. Making groups, breaking groups, combining groups, they're how we learn to count, sort, and reason. But they're way more important than any of us could have imagined. In fact, they have their own branch of mathematics, set theory, which uses logic to explain why the rest of math works. Sets are groups. They're usually groups of numbers, but can contain anything. The things in the set are elements, and they come from a universe. The universe is not the starry void you're thinking about. When making sets, you get to define that universe. My universe is my school. It has thousands of students. Let's take the 20 in my math class. We have a set of 20 elements, but if a student were absent one day, the students left would no longer be the same set. They'd be a subset. A subset is a set in which every element comes from a given set and only that set. What if everyone ditched math though? We'd have the empty set. The empty set contains nothing. Just like the students on a day when one was missing made a subset of the class on a day when everyone is missing is a subset. Since the empty set has nothing in it, it doesn't contain elements that weren't listed in the original set, and since the bell still rings and class is still in session, even without students, it makes sense that a version of the set, a subset, still exists. The empty set is a subset of every set. But my school has other class sets too, so it's possible to operate with them, just like with numbers in basic arithmetic. An important set operator is the union. To use it, we take a bunch of sets and merge all of their elements into one new set. If sets share elements though, we only list them once. If we took the union of class sets in my school and listed elements more than once, it would be like a student existed twice, which is, sadly, impossible. Then there's the intersection. If we took two of the classes in my school, it would be possible that they would contain some of the same students as long as they aren't happening at the same time. To intersect them, we group only the students that they share. Though a little bit harder to decipher, intersections work with more than two sets as well. Set theory becomes really useful when we want to make a list of elements with a common property, like all even numbers. We could write 2, 4, 6, 8, 10, but that list is literally infinite, and it's not practical for finding all even numbers. But since there's a rule that defines even numbers, we can use set builder notation to describe what goes into our set without listing every element. To use set builder notation, we pick a variable, which will represent any element in our set. Then we must state the condition that it must meet to be an element. Virtually every idea can be described in terms of sets. Sets also make it possible for computers to understand these ideas, and they're the basis of computer science, which is changing the way we live every day. Sets are how Google ranks and narrows down your search results, and how Amazon shows you what other customers bought along with a product. But there's so much more that can be done with them, and I can't wait to see you do it.